Welcome back to KrossUSA channel. From towering forest giants to precision milled lumber, witness the incredible journey of modern timber processing. Today, we're taking you inside America's most advanced sawmills, where German engineering meets American craftsmanship, and automation transforms centuries-old traditions. You won't believe what these machines can do. There's something almost magical about watching a towering tree transform from a forest giant into precisely milled lumber. Today, we're taking you inside a state-of-the-art American sawmill that combines old-world craftsmanship with cutting-edge German engineering from Moeringer Anlagenbau. It's a story that begins deep in the forest and ends with the building materials that construct our homes, businesses, and dreams. And our journey starts where it has for generations, in the forest. But today's timber harvesting looks nothing like the days of crosscut saws and ox teams. Modern logging operations use specialized harvester machines that can fell, delimb, and buck a tree to length in just minutes. These remarkable pieces of equipment, often weighing over 40,000 pounds, maneuver through the forest on articulated frames, their operators sitting comfortably in climate-controlled cabs, equipped with computer systems that calculate optimal cutting patterns. The harvester head itself is an engineering marvel. Hydraulic grapples grip the tree while chainsaw bars, spinning at thousands of RPM, make clean cuts through timber that might be 3 feet in diameter. Delimbing knives strip branches as the tree passes through, and measuring wheels track exact lengths before making precision crosscuts. What once took a crew of man-hours to accomplish now happens in the time it takes to drink a cup of coffee. Once felled and processed, these logs are loaded onto specialized timber trucks using knuckle boom loaders, another testament to modern hydraulic engineering. A skilled operator can stack a full load, sometimes carrying up to 25 tons of timber in less than 30 minutes. These aren't your grandfather's log trucks either. Modern logging trucks feature sophisticated suspension systems and load management computers that ensure safe transport while maximizing payload efficiency. Now here's where things get really interesting. When these logs arrive at the sawmill, they're entering a world that has been revolutionized by companies like Moeringer Anlagenbau. Founded in Germany, Moeringer has been at the forefront of sawmill technology since 1972. They understood something fundamental. The sawmill of the future wouldn't just be about cutting wood faster, it would be about cutting it smarter. As logs arrive at the mill, they first pass through a sorting and classification system. This isn't just eyeballing the timber, like in the old days. Modern mills use laser scanning technology combined with computer vision to analyze each log. The system measures diameter, checks for defects, identifies species characteristics, and even detects internal features that aren't visible to the naked eye. This data becomes crucial for optimizing every cut that follows. An Moeringer debarking system is typically the first processing step. These machines use high-pressure water jets or rotating drum systems, fitted with hardened steel teeth. Removing the bark serves multiple purposes. It protects the expensive saw blades from grit and stones, it reveals the true quality of the timber beneath, and the bark itself becomes a valuable byproduct used for landscaping mulch or biomass fuel. A modern debarker can process a log in seconds, spinning it at controlled speeds while maintaining the wood's integrity. Next comes the metal detection phase, a step that would have seemed like science fiction to sawmill operators of the 1950s and 60s. Logs can contain all sorts of metal: old fence staples, bullets from hunters, nails from property markers. These metal detectors use electromagnetic fields to identify even small pieces of ferrous and non-ferrous metals embedded deep in the wood. When metal is detected, the system marks that section, and operators can make decisions about how to handle it, preventing potentially catastrophic damage to saw blades that can cost thousands of dollars. The heart of any sawmill is its primary breakdown equipment, and this is where Moeringer really shines. Their band mill systems represent over 50 years of continuous engineering refinement. A bandsaw uses a continuous loop of toothed metal band, typically ranging from 6 to 12 inches in width, running on large diameter wheels. The beauty of a bandsaw is its relatively thin kerf, the width of cut, which means less wood becomes sawdust and more becomes usable lumber. Moeringer systems we're seeing here feature what's called optimizing carriage technology. Traditional sawmills required skilled sawyers to make split-second decisions about how to cut each log. Today's systems use that laser scanning data we mentioned earlier, processing it through optimization software that calculates the most valuable cutting pattern for each individual log. The system considers dozens of factors: current market prices for different lumber dimensions, the log's taper, any visible or detected defects, and even the grain pattern. Watch how the carriage moves. It's not just sliding the log forward, it's rotating it, positioning it with millimeter precision, adjusting for any irregularities. Hydraulic dog systems grip the log firmly, and the entire assembly can move at speeds up to 300 feet per minute through the blade. The saw blade itself is a marvel of metallurgy, high-carbon steel teeth, precisely set and sharpened, creating a cutting edge that can slice through dense hardwood or resinous softwood with equal efficiency. As each pass is made, we're seeing what sawyers call opening the log. The first few cuts remove the rounded exterior, creating flat faces. These outer pieces, called slabs, aren't waste. They go to the chipper and become raw material for paper, particle board, or wood pellets. With each subsequent pass, the log is transformed into cants, large rectangular sections that will be further processed into dimensional lumber. NTHE edge processing equipment handles these cants next. Moringer's edger systems typically use multiple circular saw blades that can be positioned independently. This flexibility means the system can process cants of varying widths and split them into standard lumber sizes, your 2x4s, 2x6s, 2x10s, and so on. The positioning is computer controlled, adjusting in real time based on the cant's dimensions and quality. Here's something that really separates modern mills from their predecessors: the trim saws and optimizing chop saws. These systems scan each piece of lumber as it moves down the line, identifying defects like knots, splits, or checks. The optimization software then determines where to make crosscuts to maximize value. Maybe a 16-foot board has a knot cluster in the middle. The system will cut it into two clear 8-foot pieces that might sell for more than the single defective 16-footer. It's making hundreds of these decisions per minute, and throughout all of this, we're seeing extensive use of conveyor systems and transfer mechanisms. Moringer integrates everything into a seamless flow. Chains, rollers, and powered conveyors move material smoothly between stations. Air-powered diverters sort lumber by size and quality. It's like watching a carefully choreographed dance where every piece of wood knows exactly where it needs to go. NTHE sorting and stacking systems at the end of the line are equally impressive. Automated lumber grading systems use cameras and sensors to classify each board according to industry standards. Select, number 1, number 2, and so on. Then, robotic stacking systems build neat packages of lumber, inserting stickers, thin strips of wood, between layers to allow air circulation for drying. A modern mill might produce 200,000 board feet of lumber per shift, and virtually every piece is tracked by computer from log to finished product. What we're witnessing here represents more than just technological advancement. It's the continuation of an American tradition that goes back to the earliest colonial sawmills. The first water-powered sawmill in America was built in 1623, and for nearly 4 centuries, we've been perfecting the art and science of converting trees into lumber. Companies like Moringer have helped ensure that American sawmills remain among the most efficient and productive in the world, producing the materials that literally built this nation and continue to build its future. If you've ever worked in manufacturing, warehousing, or logistics, you've seen countless wooden pallets. They're so common that most folks never give them a second thought. But here's the thing. Those humble pallets are actually one of the most important innovations in modern commerce. And today, we're going to show you how companies like Mega have turned pallet manufacturing into a high-tech operation that would astound anyone familiar with the traditional ways of building these essential workhorses. Now, traditional pallet manufacturing was labor-intensive work. You'd have workers cutting boards to length, nailing stringers and deck boards together, flipping heavy assemblies, and stacking finished pallets. It was hard on the back, hard on the hands, and relatively slow. A skilled crew might produce a few hundred pallets in a shift. The UMG 801.17 changes all of that fundamentally. This system starts with raw lumber, typically heat-treated wood, to meet international phytosanitary standards, which prevent the spread of insects and diseases across borders. The most common species used are southern yellow pine, oak, and various hardwoods for strength, or softwoods like pine and spruce for lighter-duty applications. The beauty of pallet manufacturing is that it can use lower-grade lumber that might not meet the standards for construction lumber, but is perfectly suitable for pallets. NTHE feeding system is where our journey begins. Raw boards enter the line through powered roller conveyors. Sensors detect each board's presence and measure its dimensions. Now, here's something interesting. The system can handle mixed sizes to a degree, automatically adjusting for minor variations in thickness or width. This flexibility was impossible in older automated systems. Next comes the optimization and cutting station. Multiple high-speed crosscut saws work in coordination, cutting boards to the exact lengths needed for different pallet components. A standard 48 by 40 inch GMA pallet, that's the Grocery Manufacturers Association standard, the most common size in North America, requires specific lengths for deck boards, stringers, and bottom boards. The cutting station processes these with remarkable speed, making clean, square cuts at rates exceeding 60 cuts per minute. NTHE chamfering station is a detail many people miss, but it's crucial for pallet quality. The UMG 801.17 includes stations that slightly round or bevel the edges of deck boards. Why does this matter? Sharp edges are more prone to splintering, which can damage products or injure workers. Chamfered edges extend the pallet's working life and improve safety. It's a small detail that makes a big difference. Now we reach the assembly stations, and this is where the UMG 801.17 really shows its sophistication. The system uses what's called a multi-station rotary assembly process. Stringers, the thick boards that run perpendicular to the deck boards and create the pallet's structure, are positioned first. The machine uses pneumatic positioning arms that place each stringer with millimeter accuracy. Then comes the nailing process, and modern pallet machines have moved beyond simple hammering. The UMG 801.17 uses high-speed pneumatic nail guns that can drive ring shank or spiral shank nails at rates exceeding 300 nails per minute. These specialized nails have superior holding power compared to smooth shank nails. Ring shanks have concentric ridges that bite into the wood, while spiral shanks twist as they're driven, creating a mechanical lock. This means pallets that can withstand years of rough handling. NTHE assembly carousel is fascinating to watch. As each pallet moves through the different stations, it's rotated and positioned precisely for the next operation. First, the top deck is assembled. Then the entire assembly is flipped, something that would require 2 workers and considerable effort manually, and the bottom deck boards are attached. The flipping mechanism uses synchronized servo motors and vacuum cups or mechanical grippers to handle the partially completed pallet safely. NTHE stacking, an output system, completes the process. Finished pallets are transferred to a stacking station, where they're accumulated in bundles, typically stacks of 5 to 10 pallets depending on the model and setup. These stacks are then banded or strapped for shipping. The entire process, from raw lumber to finished, stacked pallets, happens in a continuous flow that can produce a completed pallet every 30 to 45 seconds, depending on the pallet design and wood species. What we're seeing here represents the industrialization of what was once a fairly crude manufacturing process. It's a reminder that innovation happens everywhere in manufacturing, not just in high-tech industries. The next time you see a stack of pallets behind a store or in a warehouse, you'll know the sophisticated process that brought them into existence. We're now visiting the impressive facility that showcased different aspects of modern timber processing, the Steinberg Sawmill and Box Manufacturing Facility, with its state-of-the-art Primultini 1600 SIHC FLMRA production line. It represents the complete journey from raw timber to finished wood products. NTHE Steinberg facility has a rich history in timber processing, and what immediately strikes you is their log yard operations. Efficient log handling is the foundation of any successful sawmill operation. Logs arrive by truck and are unloaded using heavy-duty loaders equipped with specialized timber grapples. These aren't random piles of wood. Everything is organized with purpose. NTHE sorting system here uses a combination of manual expertise and automated technology. Logs are segregated by species, diameter class, and quality grade. Why does this matter so much? Different species have different characteristics. Oak is dense and strong. Pine is easier to work but less durable. Poplar is lightweight and uniform. By sorting logs carefully, the mill can optimize production runs, reduce setup changes, and ensure consistent output quality. NTHE debarking and metal detection systems at Steinberg prepare logs for processing. Modern metal detectors are so sensitive they can find a single nail buried 2 feet into a log. And trust me, in timber that's been growing for decades near old homesteads or farmland, you never know what you'll find embedded in the wood. Sawmill operators have stories about finding everything from horseshoes to old telegraph insulators trapped inside trees that grew around them. Once prepared, logs move to the primary breakdown saws. The cutting patterns here are determined by end product requirements. Steinberg produces both dimensional lumber and material for their box manufacturing operations. This vertical integration, controlling everything from log to finished product, gives them tremendous flexibility and quality control. Now let's talk about the impressive Primultini 1600 SIHC FLMRA production line. Primultini, an Italian manufacturer with decades of sawmill equipment expertise, has built a reputation for robust, high-performance systems. Here's what makes this system special: that tilting frame capability. Traditional band mill carriages move logs horizontally through vertical blades. The Primultini tilting frame can angle the cutting plane, which provides enormous advantages when processing logs with significant taper or when trying to maximize yield from irregular timber. The operator, or the automated optimization system, can adjust the cutting angle dynamically, literally chasing the best grain and avoiding defects. These ripsaws typically run at very high speeds. Blade tip speeds can exceed 180 miles per hour. At those speeds, the quality of the saw blades becomes critical. These are carbide-tipped blades, with cutting teeth made from tungsten carbide, one of the hardest materials used in industrial applications. A good carbide blade can process tens of thousands of board feet between sharpenings. NTHE integration of these 3 components, the tilting band mill, the cant holder system, and the multi-blade ripsaw, creates a seamless production flow. What's remarkable is how these systems communicate. Modern versions use industrial PLCs, programmable logic controllers, that coordinate every movement. When the band mill completes a cut, the cant holder is already in position to receive it. When the cant holder rotates the piece for optimal edging, the ripsaw blades have already adjusted to the programmed spacing. You'll notice extensive material handling automation. Lumber moves on chain conveyors, transfers between stations happen via powered rollers and pneumatic diverters, and sorting systems direct different products to appropriate stacking areas. This automation serves multiple purposes. It increases throughput, improves safety by reducing manual handling, and maintains product quality by minimizing handling damage. NTHE integration of box manufacturing at Steinberg shows the ultimate value-added approach to timber processing. Rather than just selling dimensional lumber, they're creating finished products. Wooden boxes and crates might seem old-fashioned in our age of cardboard and plastic, but for heavy industrial parts, international shipping, or premium product packaging, nothing beats a well-constructed wooden box. What we're witnessing at these facilities represents over a century of accumulated knowledge in timber processing, combined with the latest in automation and control technology. From the forests to these processing facilities, from logs to lumber to finished products, it's a testament to an industry that remains vital to our economy and our way of life. These aren't just factories. They're the modern embodiment of a craft that's been essential to human civilization since we first started building permanent structures.